Gravity is the quiet architect of motion. It shapes the path of every falling leaf, every orbiting moon, every star held in place against the dark. You don't feel it pulling on you right now, yet it keeps you anchored to a world spinning through space. It bends the trajectory of planets, curves the flow of light, and whispers the structure of the universe itself. But what if, just for a moment, gravity stopped working the way we expect? Before we begin this gentle journey into the hidden rules of attraction and falling, if this quiet exploration brings you even a moment of peace, your soft like or gentle tap on subscribe means more than you know. Thank you for being here. Now we drift into part 1. Part 1. What really happens when you let go? Extended gravity feels simple. You loosen your grip on an object and it falls. But falling is not motion downward. It's motion forward through curved space, a quiet collision between straight-line inertia and the Earth's pull. To understand a world where falling changes, we must first feel the invisible geometry we live inside every day. Take a moment to imagine holding something small in your hand. A tiny stone, a coin, a leaf. Right now, as you hold it still, there is balance. Your fingers resist the Earth's constant pull. But the instant you release it, that balance dissolves. The object begins to move, quietly tracking a path determined not by intention, but by the very shape of space around the planet. When we picture a falling object, we tend to imagine gravity as a force tugging downward. Yet Einstein gave us a deeper truth. Earth's presence curves the fabric of space-time, and what we call falling is simply the stone trying to move straight ahead, straight by the universe's definition, not ours, along a path bent by the world beneath it. If gravity felt weaker tomorrow, the stone wouldn't fall the same way. It might drift downward in a slower arc, as if hesitating, as if unsure where the ground truly lies. And if gravity disappeared altogether, even just for a moment, the stone would not rise upward. It would simply continue forward on its original path, parting the air like a tiny planet released from orbit. Right now, even as you sit still, your body is moving. Earth's rotation carries you thousands of kilometers each hour, and its orbit sweeps you around the sun at nearly 30 kilometers every second. Gravity makes sure you don't feel that motion. It ties you gently to the surface, keeping your path aligned with the ground beneath you. Falling, then, is what happens when gravity stops holding you on that curved surface. Your feet no longer follow the planet's turn. You instead take the straightest possible line through space, which, from your perspective, looks like a plunge downward. The subtle truth is this: when something falls, it is the Earth that rises to meet it, not in any measurable sense we can feel, but in the exact language of physics. Earth and the falling object move toward each other, each influenced by the other's mass. You cannot see that shared motion. Our planet is simply too massive, but it's there, woven into every drop and stumble. As you picture falling, imagine the sharpness of the air rushing past. Air, too, shapes the fall. It presses upward with resistance, a quiet reminder that our world is more than just gravity and ground. Remove the air, and a feather and a stone trace the same smooth curve. This was proven on the moon by Apollo astronauts. A feather floating down with no slow drift, only pure motion guided by gravity alone. No breeze, no flutter, just the silent truth of a universe without air. That experiment reveals something important. Gravity doesn't care what something is made of. A gold coin, a breath of dust, a drop of rain. Each falls with the same acceleration here on Earth. Your body doesn't need strength or size to obey gravity's rules. Every atom feels the same pull. Every particle shares the same fate when released. We experience falling as quick and sudden, but on cosmic scales, falling is slow and majestic. The moon is falling around Earth perpetually, always missing the ground by drifting sideways fast enough to stay aloft. Satellites, planets, stars, all are caught in this endless dance of falling and turning. Orbit isn't escape from gravity, it is falling perfectly. Now, imagine if the strength of gravity began to fade, even by the smallest fraction. The stone in your hand would still fall, but the ground would feel farther away. Your body might sway differently as you walked. A jump might lift you into a longer arc, your landing delayed by a touch of weightlessness. The world would not announce the change, it would murmur it. And as gravity softens, something else quietly rises in influence: inertia. The stone, once released, wants to retain its forward motion, wants to follow the straightest path through space-time. With less curvature to guide it downward, its trajectory stretches outward. Sideways drift becomes noticeable. Falls become flights. A world we think of as grounded begins to loosen its grip on motion. There is wonder in realizing that falling is not downward. It is outward, away from the smooth curve of our planet. Down is simply the direction that keeps you closest to Earth's center. Alter gravity, and down becomes less certain, less demanding, a suggestion rather than a rule. Even time is entangled in falling. Clocks tick differently depending on height. The higher you are, the faster time moves. This means every fall is a tiny journey into slower time, a glide into slightly deeper gravity, a shift so small you never feel it. Yet, physics notices. Measurements record it. Gravity shapes not only motion, but the rate at which moments pass. Consider your own balance. Standing upright is a constant negotiation with gravity. Your muscles make quiet adjustments to keep your center of mass aligned above your feet. If gravity eased, your posture would drift, your sense of stability dissolving into something airy and strange. Falling would start not with a step, but with uncertainty in the very idea of down. This brings us to a final thought. When you let go of something, you witness gravity's authority, but you also witness the universe's preference, that everything moves unless constrained. Motion is the default, falling is the unmasking of true trajectory. Earth's pull transforms straight lines into curves, and those curves lead everything gently home. If gravity ever changed, falling would reveal that transformation first. Objects would drift strangely, not down, but outward, as the invisible mathematics beneath our lives rewrote itself in silence. And as we continue this quiet journey, one question begins to form softly at the edge of thought. If falling is a partnership between motion and curvature, what happens when the curvature changes everywhere at once? Now we drift into the next chapter. Part 2. The force. That isn't a force. Gravity does not push or pull. It bends the stage beneath our feet. Einstein taught us that objects fall not because they're dragged downward, but because space-time itself is warped by mass. If this curvature shifted even slightly, every familiar motion would drift off course. To picture this hidden truth, imagine a quiet cloth laid out beneath everything that exists. Every star, every planet, every atom rests upon that cloth, and wherever mass settles, the cloth dips. Planets and moons follow the folds and valleys of this cosmic fabric, not forced downward, but guided by shape. This is gravity as Einstein described it, not a force in the traditional sense, but geometry given life. You never feel the bending of space-time. Instead, you feel the result. You feel the ground, pushing back against your feet. You feel weight, yet weight is only the resistance of Earth saying, very gently, you cannot take the straight path of the universe because I am in the way. And if Earth were removed in an instant, you would not be thrown upward. You would simply continue forward, following the natural line of motion that was always there, a line curved only because a planet stood beneath you. Wherever mass gathers, space-time curves. Wherever space-time curves, matter follows that bend. This is the hidden conversation that keeps the moon in orbit, keeps oceans pressed against the seabed, keeps us grounded even while the world spins beneath us. Now, imagine that curvature changing. Imagine the Earth swelling slightly in mass, perhaps by something as simple as a dense asteroid merging with its core. The curvature beneath our feet would deepen. Your weight would grow without warning. Walking would demand more. Your steps would shorten. Your heart would work harder to lift. Blood to your brain. Then, reverse the scenario. Let Earth lose even a fraction of its mass. Suddenly, the curvature relaxes. Weight becomes a softer suggestion. You might feel a lightness in your bones, a slow drift in your footing, as if the ground in your body had begun to disagree about where the center truly lies. The most delicate change in curvature could alter the rhythm of everything. Rain would fall differently. Clouds would rest in new altitudes, the shape of flames, the silence of a dropped object, the path of each heartbeat in your chest, all would adjust as the invisible geometry evolved. It is humbling to realize that stability does not arise from stillness, but from a balance of motion and curve. The path of the Earth around the Sun looks circular from our perspective, yet it is only curved space guiding a planet that is always trying to travel straight ahead. Without curvature, straight ahead would lead us into the dark. With curvature, straight ahead becomes a circle, a year, a season of returning light. This brings us to one of the quietest wonders of gravity. You are not pulled down. You are held upright in a constant negotiation between your momentum and the dip of space-time beneath your feet. Standing still is not truly still. It is motion prevented, a silent conversation between mass and geometry that never ends. Scientists test these ideas not with imagination, but with measurements so precise it borders on the miraculous. Atomic clocks placed just centimeters apart tick at slightly different rates. The lower clock, deeper in the curvature of Earth's spacetime, experiences time more slowly. This difference is tiny, far too small for our senses, yet perfectly predicted and observed. Gravity shapes not only motion, but time itself. A deeper well of curvature means seconds stretch longer. To move upward, even a single step, is to climb into slightly faster time. Each night when you lie down to sleep, your head ages a little faster than your feet, a difference so small it would take billions of years to matter, but real all the same. Now let us imagine a world where this curvature shifts unpredictably. Not enough to lift us into the air, but enough to make each step uncertain. A marble released on a table would roll toward new directions each day as the dips and valleys in space-time subtly reshape themselves. Pilots would look to the sky and find their instruments drifting off course. Satellites that rely on delicate balance would wander from their precise paths, slowly spiraling outward or inward, their silent circuits rewritten by geometry that no longer remembers yesterday. The tides would change rhythm. The ocean, guided by the dance of the moon and earth, would feel a new beat beneath its waves, a heartbeat changed by an invisible hand. Even light would reveal the change. Beams from distant stars would bend along unfamiliar paths. Astronomers would stare at constellations that seemed to shimmer with uncertainty, as though the heavens had learned to breathe differently. Gravity, this force that is not a force, is the architect of order on every scale we can perceive. It is responsible for galaxies spiraling together, for stars igniting under crushing pressure, for planets holding their atmosphere like a fragile veil. If the curvature changed too much, stars could no longer hold themselves together, their fusion engines sputtering against the loosened grip of space-time. The night sky, once steady with ancient light, would slowly unravel over eons into a quieter, more scattered darkness. Even our solar system depends on just the right amount of bend. If the sun's mass weakened, planets would drift outward, their paths lengthened into colder, lonelier orbits. If its mass grew, we would sink inward, dancing too close to the star that warms us, feeling the light become unbearable. This fragile balance, so precise and so ancient, is the reason life can exist here, on a world that does not throw us outward or pull us too hard inward. Einstein once said that gravity is not a property of space, but the story of how matter tells space how to curve and how space tells matter how to move. It is a relationship, a dialogue older than stars. To change gravity, even slightly, would be to rewrite that dialogue. A whisper altered in the script of the cosmos, a new meaning given to falling, weight, motion, time. And so, as we continue deeper into this quiet mystery, we carry a simple question. If the shape of space decides how everything moves, then what would happen if that shape loosened its grip, not just under our feet, but everywhere at once? Now we drift onward, toward a place where up and down begin to fade, and direction itself becomes uncertain. Part 3. When up and down lose their meaning. Right now, down feels obvious, but down simply points toward the center of Earth. If gravity weakened or tilted differently, your sense of direction would dissolve into a slow, floating uncertainty, like being underwater in a world reshaped from its center outward. Every moment of your life, you trust that downward is dependable. You plant your feet on the ground, and the ground pushes back with confidence. Your body balances effortlessly, guided by gravity's quiet insistence that the direction beneath you is always the same. But this familiarity hides something extraordinary. Up and down are not universal truths. They are local agreements, born from a planet curving space and anchoring motion. Imagine sitting in a spacecraft far from any world. There is no down, there is only motion and momentum. If you release a small object there, it does not fall. It floats, perfectly still relative to you, its path ruled only by the smallest nudges of air or movement. On Earth, we rarely glimpse that freedom. Here, down is so absolute that we teach it before language, before numbers, before memory. A baby who cannot yet speak can still reach toward the floor. Our bodies learn gravity's preference before we learn our own names. But gravity is not constant. It changes subtly with location. Stand at the top of a mountain, and you are slightly farther from Earth's center. There, your weight eases so gently that only the finest instruments would notice. Dive deep into a mine, and the opposite happens, your body experiencing a touch more pull. Up and down are not fixed directions, but a gradient of attraction woven into the ground beneath your feet. Now imagine a world where that pull begins to change more dramatically, not enough to lift you from the ground, but enough to make each step feel confused. You push down, and the ground returns less pressure than you expect. The muscles in your legs recoil slightly, searching for a stability that has quietly weakened. Your inner ear, trained to sense motion and tilt, begins to question its own signals. Without the strong guidance of gravity, your mind must invent new rules for balance. You might lean unconsciously, your steps drifting like those of a sleepwalker. Even lifting your head could feel strange, as though your skull were gently trying to float away from the rest of you. Deep underwater, this sensation already exists. Divers lose their sense of direction easily. When the pressure and buoyancy blur the cues of balance, they look to rising bubbles for the truth of up. Remove gravity's firmness from air, and we would become like divers on land, searching for any clue to where home lies. Consider a candle flame. Right now, it stretches upward, hot air rising as cooler air sinks to replace it. Up exists for the flame only because gravity sorts air by weight. But in a world where gravity softens, the flame becomes a sphere of gentle glow. No top, no bottom, a star in miniature. Plants would suffer a similar confusion. Roots grow toward gravity, branches stretch against it. If the signal faded, a tree might twist uncertainly. Roots exploring sideways, branches curling in. Spirals, life rewriting its shape to search for a new center. Even the ocean would lose direction. Water presses downward now, forming tides and deep trenches. Weaken that pressure, and currents would drift into stranger paths, no longer guided by the heavy pull of the seabed. Fish, so attuned to vertical gradients, would explore new layers of the sea without resistance. Your own heart would notice. Gravity helps pull blood to your feet and makes your heart work harder to return it upward. Reduce that burden, and your circulation changes. Your face might swell slightly with the rising ease of blood, your posture softening as your muscles discover there is less work to do. Astronauts have lived this reality. In orbit, their bodies forget the meaning of down. Their bones lose density, unused to carrying weight. Their muscles weaken. Their balance system becomes easily confused, sometimes tricking them into feeling upside down when floating perfectly level. Gravity is not just a force that keeps you grounded. It is a teacher of orientation and a sculptor of the body. If the Earth's center were no longer the universal target of motion, our entire sense of world would unravel. Maps rely on the idea of vertical distance. Buildings rely on foundations built against the steady push of weight. Airplanes navigate with instruments that expect down to be predictable. Your own eyes expect the horizon to remain where it is, but if gravity tilted slightly, the horizon would appear to slide. Rain might fall at an angle that feels wrong. The wind could carry scents in directions that confuse animals, birds circling in search of an upward path that has changed. Down is simply the direction that reduces gravitational potential. If that potential shifted, down would follow wherever the new curve of space-time told it to. Our instincts would need time to catch up. Imagine waking one morning to find that you feel a very slight pull to the east, barely noticeable. A pencil placed on a flat desk begins to roll gently toward the wall, not from imperfections, but from a new direction born in the fabric of space. Your home, your street, your city would not change shape, but your body would begin to learn this new down. Slowly, uncertainly, uneasily. And what if the change did not stop? What if gravity fluctuated with time, up and down, shifting like a tide? We would live in a restless world where stability fades in and out like a dream that forgets itself. There is comfort in knowing that gravity on Earth remains steady. Comfort in the familiar weight beneath you, the knowledge that down will always be down as long as this planet remains whole. But understanding that down is not universal opens a door to wonder. It reminds us that our experience of the world is shaped by forces we cannot see, forces that could have been different, forces that may one day change. So when you stand, when you walk, when you feel the firmness of Earth hold you in place, you are experiencing one of the quietest miracles of existence. Direction itself is a gift of gravity. As we drift forward, one lingering thought emerges like a soft whisper. If direction can fade, what else is held in place only by the strength of gravity's embrace? Now we move gently to the next chapter, where air itself begins to question its home. Part 4. The air would learn. New paths. Gravity holds not just us, but the atmosphere itself. If that anchoring eased, the air would begin to drift upward, thinning around the ground and pooling softly at the edges of the sky. A quiet reshuffling of breath, almost imperceptible until it wasn't. Right now, every breath you take is a gift of gravity. The oxygen surrounding you does not float away because Earth gently pulls on every molecule of air. This pressure, this invisible weight, makes the atmosphere thicker near the surface and thinner as you climb toward the open sky. You feel this on mountains. Air grows colder, the breath more difficult. Your lungs work harder for the same sip of oxygen that would feel effortless by the sea. Gravity's influence shapes this gradient, holding the atmosphere close to the ground, where plants, animals, and humans rely on it most. Now imagine that pull begins to weaken, not completely disappearing, but relaxing like a hand unclenching. The atmosphere would loosen its embrace with Earth, slowly lifting away from the ground. Breathing at sea level might start to feel like breathing at high altitude, a quiet strain entering every inhale. Weather would shift first. Wind is simply air searching for balance. Change the weight of air, and that balance becomes uncertain. Storms would wander into new territories, drawn not by heat and ocean currents alone, but by a new shape of pressure in the sky. Rain might fall in places that were once dry and pass over places that once depended on it. Clouds would rise higher, their bases drifting toward altitudes where sunlight strikes more intensely. Shadows would change shape and timing. Days could grow warmer under clearer skies, while nights cooled faster as thin air failed to hold heat close to the ground. Birds who navigate by wind and updraft would feel the change almost immediately. Wings that once pushed against a comfortable thickness would meet too much softness. Flapping would feel like flying through dreams where the air does not push back. Migration routes, travel speeds, even survival itself would need to relearn the rules. Insects would encounter a different challenge. Tiny bodies depend on air resistance to remain aloft. Gravity gives their wings purpose. With a softer pull downward, they might flutter too high, struggling to control flight paths in a sky that no longer cradles them with pressure. Even sound would transform. Every voice, every song, every echo travels through air by vibration. Thin air carries those vibrations less effectively. Conversations would feel slightly quieter. Music outdoors might seem to fade too quickly, as though the world were absorbing the notes before they could reach listening ears. Cities and architecture would adapt next. Tall buildings depend on predictable wind forces, on a stable atmosphere pressing against their structures. As that balance shifts, gusts might grow sharper at new heights, air currents twisting between towers in unfamiliar patterns. Engineers would need to study a skyline where air no longer behaves as expected. Plants would be among the earliest witnesses. Leaves rely on the density of air to carry moisture away in evaporation and to draw carbon dioxide toward their veins. With thinner air at ground level, they might grow broader and flatter, trying to capture what the sky no longer offers freely. Forests could stretch higher toward the heavens as though reaching for the missing weight of air. The ocean, too, would feel this shift. Wind stirs waves, and waves sculpt coasts. If the air rises higher, winds may weaken at the surface. The sea could become calmer in some places, yet wilder in others, where the atmosphere pools like water gathering in a deeper basin. Sailors would navigate different seas, and coastlines might erode in unfamiliar ways. Human bodies, conditioned by gravity's constancy, would sense the new atmosphere in small but persistent ways. The first sensation would be a slight breathlessness, as if climbing a hill that is not visible. Exercise would feel more strenuous. Hospitals at high elevations already know this story, providing supplemental oxygen where the air is thin. But in this altered world, that thinness would visit us all. The sky itself would begin to look different, not dramatically at first, but gradually, like a sunset changing color. The deepest blue at noon might soften toward a lighter shade. Less air means fewer molecules to scatter sunlight into the hues we trust. Starlight could become sharper at night, the cosmos appearing closer even as the air retreats upward. Satellites would encounter new paths as well. The upper atmosphere, now drifting higher, would brush against their orbits. Tiny drags, once insignificant, could grow into noticeable resistance. Some satellites might spiral downward slowly, others pushed outward by the shifting balance of air and gravity. And with these changes comes a quiet but profound truth. Air does not belong to the ground. It is here only because gravity keeps it close. Loosen that connection, and the sky reshapes itself not out of chaos but out of newfound freedom. Emergency responders would account for slower combustion in fires. Engines that rely on oxygen would lose efficiency. Jets would need longer runways to lift from thinner air. Spacecraft could rely less on atmospheric drag to slow their descent, demanding new systems to ensure safe return. Even the simple comfort of a breeze would feel different, not the same pressure on your skin, not the same cooling touch. The sensation of wind is the sensation of air density and the force with which it pushes. A world with thinner air would feel less alive to the senses, quieter, lighter, more distant. In time, life would adapt. Evolution is patient. Species would breathe differently, grow differently, move differently. But in the early days of such a transformation, there would be confusion in every wingbeat and every forecast, in every breath drawn without thinking. Through all of this, one gentle realization settles in. We take comfort in air because it feels permanent, yet it depends entirely on gravity remaining what it is. The sky is not a separate realm. It is part of Earth, held in place by the same invisible hand that keeps your feet on the ground. If gravity continues to shift in our imagined world, air will keep learning new paths, rising higher, drifting wider, until the boundaries between Earth and the open quiet of space become less certain. As we move forward, a single question follows us softly. If the air can forget its home, what might happen to the oceans that depend on gravity even more? Now we drift to the next chapter, where water begins to test its edges. Part 5. Oceans that try to leave. The weight that keeps oceans calmly cupped to Earth is simply water pressed downward by gravity's persistence. Change that weight, and tides would swell higher, currents wandering, shorelines quietly redrawn. Right now, the sea stays loyal to the planet because gravity demands it. Every wave that rises must eventually fall back, every droplet pulled downward into the basin of the world. But the balance is delicate. Water is always in motion, always testing its boundaries, held only by the strength of the unseen hand beneath it. Imagine a world where that hand loosens. Gravity eases just a little, barely enough for a person to notice in their step, but more than enough for the ocean to feel the shift. The surface would swell outward, reaching toward the sky as though remembering a freer time. Tides, which depend on the pull of both Earth and Moon, would begin to rise higher than predicted. The familiar heartbeat of high and low tides would stretch into unfamiliar rhythms. Coastal cities, built on the promise of a steady sea, would start to watch the water come a little higher each day, waves touching parts of the shore they never knew before. The ocean does not need much encouragement to change shape. Even now, storms and winds can lift the sea dramatically, reminding us that water is restless. Gravity gives it boundaries. Remove a fraction of that constraint, and boundaries become suggestions. Shallow seas would notice first. Sandbars and coral reefs might disappear beneath a deeper layer of water, their ecosystems adjusting to new pressures and shifting light. Shorebirds would search for beaches that no longer rise with the sun. Sea turtles would find ancient nesting grounds, washed away by tides that refuse to retreat. Currents would shift next. They flow now because of differences in temperature and salt, guided by the spin of the planet and the shape of the continents. But gravity also holds them close to the seafloor, pressing the layers of water into a balanced stack. Weaken that weight, and currents would rise into the mid-ocean, gliding higher, swirling into paths that had no reason to exist before. Trade winds might weaken, monsoons might follow new routes, and the ocean's secret highways of heat would carry warmth and cold into new corners of the planet. Islands would change shape. Some might flood slowly, their lowlands submerged in a silence too gradual to call disaster. Others would become cliffs that seem to rise from deeper blue, their shores eroded by a sea that refuses to stay still. And deep beneath the surface, gravity's influence is even more profound. The darkest trenches of the ocean exist because water is forced downward into the deepest wrinkles of the earth. Less gravity means less pressure. The crushing force at the bottom of the Mariana Trench would soften, allowing gases trapped in rock to escape more easily, perhaps stirring new hydrothermal vents or awakening dormant volcanic activity. Every organism in the abyss is shaped by pressure. If that pressure fades, so do the bodies built to endure it. Creatures evolved for darkness, and weight would struggle to adapt, their biology unprepared for a lighter world. Coastal human life, so dependent on the ocean's mood, would feel the change every day. Fishing routes would become unpredictable as species migrate in response to shifting currents. Harbors would need new engineering to protect against tides that ignore their old promises. Salt water might push farther into rivers, changing the chemistry of drinking water and reshaping agriculture quietly, relentlessly. Yet, in some places, a different story emerges. The weakened pull might mean gentler waves along certain shores. Beaches could widen where currents withdraw, giving space back to the land. But such gifts would be uneven, a planet rearranging its water without asking humans where they prefer the coastline to rest. Think, too, of ice. Glaciers and polar caps remain grounded not only by cold, but by gravity holding them down. With less pull, calving would grow easier, huge slabs of frozen water breaking away to float into a sea already learning expansion. Sea levels rise further, not because of melting alone, but because ice no longer feels the same commitment to the ground. Ships would ride higher in the water, more buoyant in a lighter world. Navigation charts based on known depths would need rethinking. Submarine cables and pipelines might sag into unexpected currents, their careful placement challenged by a sea that no longer presses downward as it once did. Even the color of the ocean could change. Particles that settle quickly now would remain suspended longer in water with reduced gravitational sorting. Some coasts might see brighter turquoise shallows, others murkier waters where light struggles to pierce. Of all Earth systems, the ocean is the most dynamic and the most sensitive to gravity's reign. Water lifts, flows, explores. It seeks out every possible shape. Only gravity keeps it loyal to the globe. Only gravity decides which valley becomes a lake and which becomes a desert. If we loosen that rule, the sea remembers its freedom. There is a quiet poetry in this idea. The ocean is always trying to leave. Tides stretch and strain at the shore, storms push water inland, evaporation sends droplets skyward. Gravity answers every attempt with a firm and steady no. Change the answer, and the ocean becomes a negotiator, pressing gently at first, then boldly, claiming new ground as it redefines the edges of the world. And yet, the ocean's changes would be only the beginning, because the same force that holds water to Earth also keeps the planet's surface from drifting outward. The very shape of continents depends on gravity's insistence that rock stays low and mountains rise only so high. Which brings us to a profound and unsettling realization. If water begins to forget its place, perhaps the ground beneath it will too. As we drift forward in this quiet reimagining, a new question waits beneath the waves. If gravity continues to give up its hold, will the spin of the Earth begin to take control instead? Now we move to the next chapter, where the world's rotation wakes from the background and becomes the new architect of motion. Part 6. The Earth's spin would take over. Without gravity holding things close, centrifugal motion from Earth's rotation would rise into power. Objects would begin to drift sideways, not falling down, but drifting outward, motion guided not by weight but by spin. The Earth is constantly turning. Every point on the equator moves at over 1,600 kilometers per hour as the planet spins beneath the stars. Right now, gravity keeps everything attached firmly enough that we never feel this motion pushing us outward. But that outward push is always there, balanced by the invisible pull of the Earth. If gravity weakened, even a little, that balance would shift. A ball you dropped would not fall straight down. It would slip outward as the planet spun beneath it, a curve in motion that reveals the hidden tension between gravity and rotation. You might take a step and feel as though you were drifting ever so slightly toward the horizon. Chairs would slide, glasses would tilt, water in a cup would gather toward the rim instead of resting calmly at the bottom. Everything around you would behave as though the ground were leaning away from you, even while it appeared perfectly flat. This outward drift is not imagination. It is physics waiting for its chance to take charge. Centrifugal motion is the quiet counterpoint to gravity. It pulls outward while gravity pulls inward. Together, they create the weight you feel and the way the world holds itself in place. Weakened gravity and rotation begins to write new rules. At the equator, where Earth spins fastest, this effect would be strongest. People living there might feel a gentle lift with every movement. Their bodies would sway off balance as the ground no longer claimed them with the same certainty. At the poles, the change would be subtle. Rotation there is slower, so the outward push is weaker. Up and down would remain more familiar, like the world you know holding on just a little longer. But closer to the equator, the effects would build slowly like a tide of motion rising through every object. High buildings would need reinforcement as their weight no longer pressed straight down. Elevators would travel on slanted paths as shafts warped under shifting forces. Roller coasters, carefully engineered for weight and speed, would become unpredictable. Even a child on a swing would trace a path that pulls strangely sideways. Travel would change as well. Airplanes would need to correct constantly for a drifting atmosphere being flung outward by the rotation of the planet. Pilots would see new wind patterns and turbulence where once there was calm. Navigation systems built on centuries of gravitational reliability would struggle to adapt. The ocean, too, would respond. Earth's rotation already shapes its surface, making it bulge slightly outward at the equator. With less gravity to hold it in, that bulge would grow. Water would migrate toward the equator in a slow but unstoppable flood, deepening seas and drowning coastlines along the middle of the planet. Islands might vanish beneath the new outward tide. Meanwhile, the poles could rise from the water, their seas draining gradually as the planet's swirling motion claims dominance. What once defined geography would be rewritten by a new equilibrium between mass and spin. Even the air would take new paths. The atmosphere would stretch outward with the water, gathering more thickly along the equator and thinning near the poles. Breathing could feel heavier and tropical. Regions and more difficult near northern and southern lands. Weather patterns would shift in ways no forecast could predict. Inside your inner ear, a more personal transformation occurs. The vestibular system, which keeps you balanced and oriented, depends on gravity as its reference. Change that reference and your brain must guess what direction motion is truly happening. You might suddenly feel as if forward and downward were trading places, a dizzying confusion that comes with a changing world. Sports would become surreal. A ball kicked into the air would arc sideways before falling. Athletes would learn new physics through every throw and leap, their muscles adjusting to forces that do not follow the rules they learned as children. Even buildings anchored deep into the crust would need to brace differently as sideways pressure on their foundations rises quietly. Engineers would study a world that feels tilted without appearing tilted. Every structure would need to respect a new center of balance, shifting slightly outward with each passing day. People would notice the change in the stars too, not because they move, but because we would. If the planet's rotation takes the lead, time zones drift, sunrise and sunset arrive with strange delays, and the sky's ancient patterns shift into slow uncertainty. This transition would not be violent at first. It would be subtle, gentle, almost polite. A small drift in a dropped pen, a quiet slide of water in a glass, a slight lean in posture as gravity's grip begins to exhale. But as days turn into months, the difference would grow undeniable. Earth's rotation, once a background hum, becomes a sculptor of reality. There is a deeper implication here. Gravity does not just hold us down. It keeps the centrifugal forces of rotation from tearing our world apart. If gravity continues to weaken, Earth's ability to remain whole begins to falter. Rocks and soil lift. Mountains erode from below as the crust subtly relaxes outward. Landslides could become more common, not from rain, but from the planet trying to reshape itself. This is not destruction, but transformation. A slow awakening of the motion we always ignored. And still, one more question emerges quietly from the turning of the planet. If the outward pull of rotation grows stronger, objects not anchored firmly might begin to drift away completely. Dust, pebbles, drops of water, they would no longer know where home is. The Earth would not stop spinning, but we might begin to lose our hold on it, which leads us naturally forward. If the outward tug of rotation can loosen the ground beneath us, what then happens to the moon that depends on Earth's gravity for its own perfect path? Now we drift into the next chapter, where our companion in the sky begins to test the limits of its eternal orbit. Part 7. The Moon's Escape. Our moon is a prisoner of Earth's gravity, locked in a slow, circling embrace. If the force weakened, even slightly, the moon would begin to slip away, a companion drifting into the dark, leaving tides confused and seasons undone. For billions of years, the moon has been our silent partner. It pulls on the oceans, guides the tides, stabilizes the tilt of Earth's axis, and helps create the rhythm of climate and seasons we rely on. Yet its loyalty is conditional. It stays because gravity asks it to. Change that request, and the orbit begins to unravel. Visualize the moon in its delicate balance. It tries to travel straight through space, yet the curve of Earth's gravity constantly bends its path. Orbit is falling perfectly, missing the ground with every moment, held in place only by a force that does not allow it escape. If gravity weakens, that perfect fall becomes a wider arc. The moon drifts outward inch by inch, night by night, its tether loosening in silence. Right now, this is already happening. The moon slowly retreats from Earth each year because tides steal a little energy from the orbit. But if gravity itself were fading, this quiet separation would accelerate dramatically. At first, nothing dramatic would be visible to the naked eye. The moon would look the same in the sky, round and bright and familiar. But astronomers would notice its path widening. Lunar eclipses would shift in timing. High tides might arrive minutes later each month. A subtle drift, but one with deep consequences. The tides themselves would begin to misbehave. Ocean waters, once guided predictably by the moon's pull, would lose rhythm. Some coasts would experience weaker tides, the daily rise and fall becoming a smaller gesture. Others could see chaos if winds and storms fill the void left behind. New patterns emerging where ancient cycles once prevailed. Marine life has evolved around the tides. Crabs, turtles, coastal birds all depend on precise water levels. Change the timing or height of the tides, and migration, breeding, and feeding begin to scramble into unfamiliar cycles. This confusion would ripple through ecosystems, a quiet disruption in the heartbeat of the coast. On a larger scale, the moon also steadies Earth's rotation. Our planet is tilted, which gives us seasons. The moon keeps that tilt from wobbling too wildly. Without its steadying influence, Earth could begin to lean and shift unpredictably. Imagine summers growing hotter, winters colder, spring and autumn shortened or stretched. Weather systems would search for new anchors as the planet's rotation drifts into a slower sway. What once felt like a reliable cycle would become fluid and uncertain. The night sky would change as well. As the moon recedes, it would appear smaller, its glow dimmer. Eclipses would become rare treasures, shadows no longer aligning as they once did. Poetry, mythology, navigation, even the comfort of moonlight would retreat into memory. For astronauts and space agencies, the lunar goalpost would drift. Missions planned for decades would need to account for a farther destination, a moving target in the heavens that demands more energy to reach. If gravity continued weakening, there's a point where the moon would reach escape velocity. In that moment, the partnership dissolves forever. The moon would drift into a lonely orbit around the sun, becoming a wandering world, no longer tied to Earth's story. Without the moon, nights would grow darker, stars would take center stage, but the familiar guardian of the night would be gone. Tides would shrink to a fraction of their former strength, driven only by the distant pull of the sun. Beaches would change shape, river mouths would adjust their flow, the coasts of the world would redraw themselves over generations. Yet the most profound shifts would unfold over thousands of years. Earth's axis would wobble wildly, like a spinning top losing balance. The stability that allowed complex climates to flourish would waver. Regions that once grew lush and green could freeze under shifted sunlight. Deserts might bloom with rain only to dry again in unpredictable cycles. Humans, moved by memory and meaning, would feel the loss deeply. The moon has been a calendar, a guide, a symbol. We trace time in its phases before writing existed. Its disappearance would leave a psychological emptiness, even as the physical world struggled to adapt. Planet Earth would also feel lighter in another way. The gravitational bond with the moon creates a tidal bulge on the planet itself, slowing Earth's rotation minutely over time. Without that influence, the days might become shorter again, spinning faster as the moon escapes. Time itself, measured in sunrises, would shift its pace. We often think of gravity as a constant we can count on. But this chapter reminds us that the cosmos holds its relationships delicately. Planets and moons are companions only, while the forces between them remain strong enough to bind. If gravity keeps weakening, the outcome is inevitable. The moon leaves, tides change, seasons stumble. The rhythm of Earth loses its most trusted conductor. And still, a deeper question lingers. The moon is not the only object held by Earth's gravity. We are not alone in this delicate balance. Satellites orbit above us, space stations, debris drifting from past missions. Even the atmosphere itself remains only because gravity keeps it near. If the moon can escape, so can everything else, which leads us forward into the next quiet revelation. If gravity weakens further, it is not only the night sky that changes. The entire solar system begins to reconsider its choreography. Now we drift to the next chapter, where our planet's place around the sun is no longer guaranteed. Part 8. A sky no longer stable. Gravity shapes the highway of planets and stars. We rely on its predictable curve to keep Earth moving smoothly around the sun. But if that curve relaxed, our orbit would stretch, growing wild and uneven, a quiet drift toward cold or heat with no way home. Right now, our planet occupies a narrow and precious lane, a ribbon of stability that allows water to flow, forests to grow, and life to continue with comforting predictability. We call it the habitable zone. Too close to the sun, oceans would boil into steam. Too far, they would freeze into silence. Gravity keeps us exactly where we must be. Picture Earth moving through space, always trying to travel straight ahead, yet constantly redirected by the sun's immense gravitational pull. This interplay creates an orbit that repeats with gentle precision. Years pass the same length, seasons return in perfect sequence, and the path we follow through the stars remains a trusted constant. But weakened gravity and that delicate choreography begins to falter. Our orbit would stretch, Earth drifting slightly farther at one point in the year, then pulled not quite strongly enough to return to the path we know so well. The ellipse we travel along would widen, a subtle change at first, but one that grows with every revolution. Summer might arrive with a harsher blaze of sunlight as Earth lingers too long in warmth. Winter might deepen, longer and colder than memory knows. Climate would not break suddenly, but unspool into unpredictability. We would still circle the sun, yet it would be a wandering circle, a journey without the old guarantee of return. Plants and animals rely on the steadiness of seasons. Birds migrate based on light and temperature. Trees bud and shed leaves in rhythm with the climate. When that rhythm becomes irregular, ecosystems wobble at their core. A mismatch between flowering plants and pollinators, animals arriving too early or too late for food. Life adjusting, struggling, improvising in a world losing its metronome. Humans would sense the change in every calendar. Planting seasons would slip out of alignment. Cities built to withstand certain temperatures would face extremes outside of their design. Heat waves in unexpected months, snow falling days after summer, has begun. Insurance, agriculture, infrastructure, all challenged by nature's new uncertainty. And the sky would tell the story visually. The sun might rise slightly off its usual path, solstices and equinoxes drifting away from their familiar dates. Even ancient constellations would seem to move differently overhead, their seasonal placements shifting quietly as Earth's orientation grows less anchored. Astronomers track the stars as if they are stationary, but they are trusting our orbit to remain unchanged. If that trust erodes, the maps of the heavens must be constantly rewritten. Even length of day is tied to gravitational balance. The moon's pull slows Earth's rotation very gradually, but if the gravitational dynamic shifts, that slowing could begin to accelerate or reverse. Days could shorten or lengthen in ways no clock was built to follow. Consider the planets around us. They too depend on gravity to preserve their own orderly lanes. Venus, Mars, Jupiter all orbit in harmony, because gravity tells them where to travel. If Earth begins to stray even slightly, their gravitational influences might nudge us further. One orbit slips, and the rest begin to tug in response. Over centuries, Earth could drift toward a new path entirely. Perhaps closer to the sun, where heat becomes relentless and the oceans thin into haze. Or outward toward colder reaches, where ice slowly conquers the continents and the cycle of life must shrink inward to survive the chill. Gravity is not only an anchor, but a safeguard against the chaos of freedom. If its strength changed enough, Earth might one day reach a breaking point. Our orbit could stretch beyond stability. A tipping point might be crossed where instead of circling the sun, we begin to drift away from it completely. Imagine a world slowly pulled into the dark between stars. Days grow dim, temperature falls sharply, and life clings to the last pockets of heat from the fading memory of starlight. Earth becomes a wandering planet, adrift without a sun to guide its seasons or warm its seas. There is also the opposite possibility. A weakened gravitational relationship might let Earth fall inward on a new trajectory. We could spiral closer to the sun, each orbit warmer than the last, oceans rising in vapor, clouds turning the sky into a blinding white shell until the world becomes an uninhabitable furnace. Either outcome is a slow unraveling, a loss of cosmic guidance that has always been steady. And through it all, the human mind would struggle with a deeper emotional truth. We take comfort in the sun rising and setting with dependable grace. We trust the sky to remain familiar. This trust comes from gravity, the quiet architect of celestial order. If the sky starts to drift and the sun's path grows unpredictable, the world might feel as though it is forgetting itself. Yet, even as we imagine this, another realization waits quietly. Earth's orbit is not the only thing held in place by gravity's strength. Every object in the solar system shares the same invisible bond. Planets keep their moons, stars keep their planets, galaxies keep their spirals, and we keep our home all because gravity gives structure to motion. So if gravity loosens its grip everywhere, the instability would not end at the edge of our atmosphere. The sun itself would struggle to hold its family together. which carries us forward to a grander scale of uncertainty. If Earth can wander from the sun, then stars can loosen their hold on planets, and galaxies might begin to drift apart. Now, we drift to the next chapter, where the very body you live in begins to feel gravity's changing story, not through motion among the stars, but through the silent biology of blood and bone. Part 9. The silence in your body. Every heartbeat depends on gravity. Blood flows downward with its help, muscles strengthen against its pressure. Without it, the body begins to forget how to stand, bones losing memory of weight, balance dissolving into softness. Gravity is not simply a force acting upon you. It is a quiet collaborator in your physiology, present in every breath, every step, every beat of your heart. Right now, as you sit or lie still, gravity is guiding the flow of blood through your veins, helping your circulation settle into a rhythm that life has trusted since its beginnings on land. Your bones are not rigid because they must be. They are rigid because they are asked to hold you upright. Every moment spent standing or walking applies a gentle stress that tells bone cells how strong they must remain. Take away gravity and the message fades. Bones begin to grow hollow, density dissolving, as the body decides it no longer needs the strength required for a world with weight. Astronauts know this transformation intimately. In orbit, they float as if resting in a dream that never ends. But with that lightness comes a hidden cost. Their bones lose mass at an alarming rate, muscles shrink, and the heart weakens because it no longer has to fight to pump blood upward from the feet. Within days, the body learns that it does not need to work as hard. Within months, it starts to forget how. Your sense of balance is a delicate conversation between your inner ear, your muscles, and the gravitational pull beneath you. If that pull fades, the conversation becomes uncertain. You might turn your head and feel momentarily lost, unsure which way the horizon lies. You might stand and sway gently, like a ship adjusting to a new tide. Walking would feel effortless at first, your steps lighter, your posture more relaxed. However, this ease is deceptive. The muscles in your back and legs would begin to weaken without the constant training that gravity provides. Standing for long periods would become a challenge, not because it is heavy, but because it requires awareness that starts to fade. Even breathing would change. Gravity helps pull air into your lungs and enables the diaphragm to push back. With less downward pressure, your breaths might feel shallow, your lungs expanding differently, your chest adjusting to a new rhythm of inhalation and release. Blood would circulate upward more easily, pooling slightly in the head. Faces may appear flushed and swollen as fluid redistributes itself without the familiar pull toward the feet. Headaches and sinus pressure would become common companions in this new gravity. Your heart, no longer facing the challenge of lifting blood against force, would begin to shrink in muscle tone. A weaker heart is not immediately noticeable, but gravity's silence slowly erodes endurance. What once felt like a short walk might leave you winded. Vision, too, would be affected. In a world with less gravity, pressure around the eyes can shift subtly. Astronauts often experience slight changes in sight, the shape of the eyeball altering as fluid redistributes. Words may blur, depth perception might distort, even looking forward becomes intuitive. Adaptation. Your immune system relies on movement and stress to maintain vigilance. In a low-gravity life, your body might become more susceptible to infections. White blood cells respond differently when gravity no longer shapes the pathways of circulation. All of this paints a picture, not of injury, but of forgetting. The body does not break when gravity weakens. It simply unlearns its structure. Muscles unlearn tension, bones unlearn strength, balance unlearns direction. There are parts of the body that would feel relief. Joints bearing less stress might ache less. Spines carrying lighter loads might stretch into new ease. Some would welcome this brief honeymoon of softened gravity. But adaptation demands balance. The health we experience now is built on the expectation that gravity remains steady. If it falters, our biology must renegotiate every function. Children born into a world with weaker gravity would grow differently. Their bones lighter, their frames taller, their muscles learning a different definition of strength. Future generations might evolve forms better suited to floating than standing. Even the heart, that ancient pump of life, would adapt over time to become smaller and more efficient within a body that no longer fights against weight. Sleep would change too. Right now, gravity influences how the body settles into rest, drawing fluid downward, helping us feel grounded. Without that sensation, some might struggle to feel fully relaxed, their bodies hovering between tension and calm. Gravity is also a guide for our proprioception, the awareness of where our limbs are even with eyes closed. Remove the guide and movement becomes uncertain, the brain forced to dedicate more attention to simple actions once performed without thought. This gentle pressure we live under is not an inconvenience. It is a teacher, a constant reminder of where down lies and how to rise against it. If gravity continues to weaken, the silence inside our bodies would grow louder. Systems designed for resistance would drift into ease, and ease becomes vulnerability when change continues. As we imagine this transformation, one truth settles softly beneath it all. We are built for Earth as it is now, not as it might become. And yet, this is only the beginning. Gravity does not only shape bodies, but behaviors. Fire, one of humanity's oldest companions, depends on buoyancy and weight. Without gravity's instruction, even flame must learn an unfamiliar form. Now we drift into the next chapter, where light and heat learn to float. Part 10. Fire that floats. Even flames depend on falling, hot air rising, cool air sinking. Without gravity's gentle sorting, fire becomes a quiet sphere of heat. No flicker, no dance, just a silent glowing orb suspended in calm. The flames you know on Earth are performers, constantly adjusting to the upward pull of buoyant air. Heat rises, cool air rushes in to replace it, and the flame stretches itself upward, a bright teardrop always reaching for the sky. Its shape is not chosen by chemistry, but sculpted by gravity's steady hand. Take gravity away and fire loses its choreography. No up, no down, no air force to trade places. Burning becomes something unfamiliar, a sphere of light that forms itself into perfect symmetry. It glows gently, without the restless movement that defines flame here on Earth. Imagine lighting a candle in a world where gravity has softened. The flame would first waver, as if unsure which direction to follow. Then, it would gather inward, forming a round cluster of heat hovering above the wick like a tiny sun. The smoke would not rise, it would simply drift, spreading outward evenly in all directions like ink dissolving into water. This lack of direction is beautiful, but it reveals the hidden complexity of fire. Flames do not merely burn, they move with purpose because gravity directs their breath. On Earth, fire feeds on oxygen drawn upward by warm air escaping. In low gravity, that upward escape slows dramatically. Fresh air arrives slowly, winding its way through the surrounding stillness. The flame burns weaker at first, its hunger unmet. Only the slow diffusion of oxygen keeps the reaction alive. Astronauts who experiment with combustion in orbit describe flames that behave like living lanterns, breathing quietly without a flicker. There is no roar, no crackle, just the soft shimmer of heat. Fire alarms designed to detect rising smoke would fail in such a world. Safety systems built on the promise of upward motion would need complete rethinking. Even firefighting becomes uncertain when flames do not climb walls or spread predictably. Consider a campfire. Right now, heat lifts sparks into the sky like tiny stars, each one a fragment of chemical transformation. Without gravity, sparks float outward, gliding slowly through the air like fireflies freed from a rhythm they once obeyed. The randomness of their motion could be beautiful and dangerous. Cooking would become a new art entirely. Flames that refused to rise would not lick the bottom of a pan. Heat would distribute differently, meals heating slowly and unevenly. Boiling water would not bubble, for bubbles rely on buoyancy to rise and burst. Instead, steam would form inside the liquid, remaining trapped as pockets of gas until the water finally releases them violently or not at all. Even candles, symbols of warmth and memory, would lose their familiar charm. A glowing orb where a flame once danced may seem alien, a reminder that comfort itself is born from forces we take for granted. But the transformation of fire is not only a matter of sensation. It speaks to the heart of energy exchange in our world. Heat spread evenly in all directions creates environments where danger is both slower and more subtle. A fire might smolder longer, hidden from sight, consuming fuel quietly until it suddenly expands without warning. Engineers would face a new challenge understanding how to manage combustion when fire does not reveal itself loudly. Every engine, every furnace, every system that burns depends on gravity's guidance. Cars might struggle to ignite, aircraft engines may falter, and power plants would need a complete redesign to harness flame's new form. Fire is also a storyteller. It tells us about danger and comfort, about ritual and discovery. Its movement speaks of direction, its warmth promises safety. Without that motion, the story becomes abstract, a whisper where a roar once lived. There is another side to this, a gentler transformation. Without the upward rush of heat, a flame's energy remains closer to the source. It glows without whipping into chaos. Perhaps it would feel more peaceful, like a tiny star that refuses to be rushed. Oxygen sensors and detectors, built to notice changes in airflow, would need to become more sensitive. The fire itself would not warn us like before. No high-reaching flames to catch the eye. A quiet sphere of combustion could hide in a corner, soft and silent, like a candle that forgot how to flare. This is the shift gravity's change would bring. Not destruction at first, but uncertainty. Not chaos, but unfamiliar stillness. Fire teaches us that motion is not always visible. Sometimes it is written in how heat rises, how air moves, how direction is defined by a force we do not see but feel every moment. If gravity continues to fade, fire's behavior is only the beginning. For where fire goes, light follows, heat follows, life follows. And this raises a deeper question. If the basic act of burning changes shape, what becomes of the other fundamental exchanges that keep our world alive? We begin to understand that a softer gravity does not simply make things lighter. It alters how energy flows, how warmth travels, how chemistry remembers its steps. The next transformation awaits in the simple act of letting go. Dropping something and watching it fall is part of our instinct. We trust the ground to meet us in a reliable way. But in this changing world, falling becomes something strange, a motion without direction, a journey that does not hurry. As we continue our quiet exploration, we turn now to the nature of falling, where gravity's weakening presence reimagines the meaning of downward motion itself. Now we drift into the next chapter, where falling becomes a slow, uncertain negotiation with time. Part 11. When falling slows to a pause. Imagine dropping an apple and watching it drift downward slowly, as though the air had grown thicker, as though time itself were hesitating. This world would feel like a dream where every motion resists waking. Right now, falling is quick and certain. The moment you release something, gravity claims it, bringing object and earth together in a single swift path. But falling is not simply motion downward. It is the most direct expression of how gravity sculpts our experience of time and space. If gravity weakens, falling becomes less like surrender and more like indecision. Objects linger in the air, their descent turning into a slow drift. An apple slipping from a branch might hover long enough for you to reach out and catch it again, the familiar plummet replaced with a gentle glide. The world would feel suspended, as though movement were wrapped in layers of softness. Every step becomes a careful float, your foot meeting the ground with a brief moment of weightlessness before settling again. Children would giggle as they tossed balls into the air and watched them return more like balloons than stones. Playgrounds would overflow with wonder, every jump transformed into a tiny moment of flight. But beneath the delight rests a change far more profound. The predictability of motion begins to unravel. We are used to gravity's certainty, its insistence that actions produce swift consequences. Drop a glass and it shatters. Let go of a tool and it returns to the ground. Cause and effect feel immediate. In a softer gravity, that immediacy fades. Dropped objects take their time, choice stretching into seconds. The simple act of falling becomes a slow conversation between motion and air. Sports would become surreal. A basketball, once dribbled sharply to the floor, would fall sluggishly as though reconsidering every bounce. Athletes would learn new timing, their muscles relearning how long a moment truly lasts. Even walking would demand new patience. When your foot leaves the ground, it would float longer than your balance expects. Every stride would feel like stepping through a slow-motion dream, each transition softened by the lack of urgency. Construction crews would watch tools descend so slowly that danger takes on a different shape entirely. Not sudden accidents, but quiet mishaps that unfold in gradual motion. Nature would adjust as well. Raindrops falling from the clouds would sway gently, drifting sideways in the wind like tiny dancers unsure of where to land. Storms would look more like fountains suspended in air, water droplets hanging before returning to the earth. Snowflakes would take even longer. A snowfall could last for hours even after the clouds clear, flakes lingering between sky and soil in a quiet ballet of slowed descent. Rivers would change their flow, as water rushing over edges must first fall through air before rejoining the stream. Waterfalls might look frozen mid-cascade, their movement so gradual that photographers would no longer need a long exposure to capture their silk-like shapes. Insects would flutter strangely, wings working against an atmosphere that no longer promises a swift return to the ground. A bee missing a flower could tumble in slow spirals before finding its way back to nectar. Birds might glide with new elegance, their landings drawn out into smooth, floating touchdowns, guided not by force, but by patience. Human reflexes would struggle to adapt. We rely on gravity to give motion a clear ending. Without that clarity, reactions become uncertain. Catching something dropped requires waiting, judging a slower descent and adjusting to a timeline that does not match instinct. This change would seep into daily life quietly. Opening a drawer might release items that drift upward slightly before deciding where to settle. Spilled water could hover in a trembling sheet before falling into droplets that wander lazily to the floor. Even accidents change character. A person tripping would not crash downward with immediate consequence. They would tilt, float, and touch the ground with an odd softness that might feel almost graceful if not for the uncertainty of where down truly lies. Our relationship with time would shift as well. We equate the speed of falling with the passage of moments. A dropped object races downward, and we feel time rushing with it. Slow that fall, and time feels thicker, slower, less decisive. Waiting becomes more common. Patience becomes necessary. Tasks take longer, not because we move slower, but because the world responds with quiet delay. Artists and filmmakers would find inspiration in the new physics of falling. Scenes once enhanced by special effects now unfold in everyday reality. Movement becomes poetry written in slower strokes. Yet, there is a shadow here too. The soft delay in falling reveals a deeper disruption. Gravity is not only a guide for motion, but a measure of certainty. We trust the world because we trust its rules. A weakening gravity introduces uncertainty into every gesture. Climbers would find that slips no longer end quickly. Skydivers would drift for hours before touching ground. Parachutes might become unnecessary, their role replaced by the gentle hesitation of descent itself. Machines would need re-engineering. Cranes, elevators, assembly lines, all designed with gravity's strength in mind, would struggle to deliver materials and goods in predictable timeframes. The entire rhythm of work might slow to match the air's reluctance to let things fall. The emergency alerts we rely on so heavily would require rethinking. Fire alarms, sudden evacuations, quick reflexes all exist because falling and danger often arrive together. In a world of slow descent, danger becomes a patient storyteller, warning us softly rather than striking fast. But it is not only speed that changes, direction does too. Without gravity's firm conviction about where down lies, falls might take odd paths curving sideways or drifting upward briefly before settling into a slow decline. We would live in a softer physics where motion negotiates rather than obeys. And as this strange new motion enters the familiar rhythms of life, one more understanding begins to surface. If falling becomes hesitant, if objects take their time finding the ground, then the boundary between earth and sky must loosen as well. the edge of our world that holds air close, that protects us from the silent vacuum above, depends entirely on gravity's strength. So the next question arrives like a soft horizon. If gravity continues to fade, what becomes of the boundary between atmosphere and the vast empty space beyond? Now we drift on to where the sky itself begins to unravel. Part 12. Space would knock at our door. Gravity guards the thin boundary between Earth and the void beyond. We forget that space is always trying to expand into the atmosphere, that vacuum waits just above our heads. Change gravity, and the edge of the sky would begin to unravel. Right now, our atmosphere clings to Earth as a layered blanket, thick at the ground, thinner at the mountains, and fading gradually into the cold emptiness of space. Gravity keeps those layers in place, holding the air close enough for life to breathe and weather to form. Just beyond the highest clouds, the pressure drops to almost nothing. Space is not far away. It is only the quiet pull of Earth that prevents the air we breathe from drifting outward, becoming part of the vast silence. If that pull softened, air would begin to rise, stretching the atmosphere like a balloon slowly inflating. The sky would become taller, reaching farther into what was once vacuum. At first, we might notice nothing. A slight change in how deep a breath feels, a gentler resistance as the wind touches our skin. But the air we take for granted would start slipping upward, molecule by molecule, like mist climbing a staircase to the stars. The boundary between sky and space would blur. The air at ground level would thin more quickly than we expect. Every breath would carry a little less oxygen. Each step uphill would feel a little harder. Cities at higher elevations would suffer first. People there would be forced to acclimate to thinner air or move downward toward what remains of breathable sky. The protective blanket of atmosphere would spread too thin. Ultraviolet radiation would pierce deeper, increasing sunburns, altering ecosystems, and challenging life that has always trusted the sky to filter out the most dangerous light. A new kind of global altitude sickness would become part of daily life. Airplanes would need to fly lower to remain within thicker air. The comfortable cruising altitudes of today would become too thin for engines to breathe efficiently. Flight paths would change, navigation shifting to match a new geography of air and void. Weather would stretch vertically. Storms could grow taller and stranger, their thunderheads reaching heights where lightning meets vacuum. Clouds might flatten as their upper edges touch a region that no longer supports condensed water. The auroras, normally confined to high altitudes, could descend lower in the sky, dancing above cities, beautiful but signaling change in Earth's magnetic shield and atmospheric reach. Satellites orbit in a delicate balance between gravitational pull and the faint drag of Earth's upper air. As those upper layers rise, drag would increase. Some satellites would begin to lose altitude slowly, spiraling downward unless boosted back into place. Space debris, too, would alter its path. Objects once safely distant might drift into lower orbits, adding to the hazard for spacecraft and stations. And then, a subtle danger grows stronger. The atmosphere protects us not only from radiation, but from small meteoroids. Most burn harmlessly upon entry because they encounter dense air. As the atmosphere rises and thins, more of those rocks might survive the journey, reaching the ground with sudden and unexpected impact. Space, once held at bay, would begin to trespass. At ground level, water would evaporate more quickly. The sea and air would trade moisture differently, weather shifting in a slow metamorphosis toward unfamiliar balance. Plants, designed to breathe carbon dioxide in a specific concentration, would strain to pull what they need from thinning air. Forests could shrink, crops could weaken, and regions that rely on predictable agriculture would find food more difficult to cultivate and harvest. People would adapt technology first, oxygen systems becoming common in homes and public spaces. Outdoor labor would require equipment as thin air challenges endurance. Athletes would rewrite what it means to train the body under a gravity too light to hold the breath close. Even sound would change its character. Voices would carry less distance, muffled by sparse air molecules. Conversations outdoors would feel more intimate, as if the world were listening quietly and letting fewer echoes stay alive. Yet the most profound change happens at the edge where the atmosphere meets the void. The sky would darken even in daylight. Sunlight scattering less means the blue fades, revealing stars faintly as Earth's cloak grows transparent. That boundary, once a safe harbor between life and nothingness, would become fragile. Space would not arrive with speed or noise. It would seep, a quiet, inevitable climb of cold and emptiness. We might look upward one evening and feel uneasy without knowing precisely why. The sky, while still beautiful, would look older, stretched too thin, its color bleached by the thinning of the air. If gravity continued to fade beyond this point, a threshold would be crossed. Atmospheric molecules could reach escape velocity more easily. Air would leak into space faster than Earth could replenish it through volcanic gases or chemical reactions. Breath by breath, our planet would exhale its life-supporting air into the cosmos. Mountaintops would become uninhabitable, then cities, then valleys. People might move underground where pressurized habitats simulate the world we lost. Earth would begin a slow transition toward becoming like Mars once was, a planet that likely held oceans and air until gravity's grasp let them float away. And with each step downward in atmospheric security, one truth would sharpen. Space is not above us. It is around us, always trying to enter, always waiting for a break in the protection gravity provides. If gravity keeps fading, the stars do not grow farther. They grow closer. Their environment becomes ours. Which brings us to a deeper realization. If the sky unravels, then even light, the most constant traveler of the universe, will begin to change the path it takes to reach our eyes. Now we drift to the next chapter, where the bending of light and the shape of the horizon begin to betray the world we once knew. Part 13. Light would curve differently. Gravity bends the path of light. If its strength shifted, every sunrise and moonrise would tilt into new shapes, the horizon bending wrong, the constellations slowly wandering from their ancient maps. Right now, light is a patient traveler, guided by the silent shape of space-time. As it moves, gravity curves the fabric of the universe beneath it, bending each ray ever so slightly. This bending is subtle. You do not notice it when you look across a quiet field or up at the stars on a clear night, but it is always there, a gentle correction to the path of illumination. Gravity tells light where to go, and light listens. If that guidance weakens, the choreography of the sky begins to drift. The sun, breaking the horizon each morning, would rise in a location that feels minutely incorrect. The curve of the dawn light, once smooth and predictable, would bend differently around Earth. Shadows would stretch in unusual directions, arriving with an uncertainty that feels like waking from a strange dream. The moon, too, gliding through phases as it climbs the heavens, would no longer rise and set in perfect accordance with memory and expectation. Lunar light would arc slightly askew, a familiar companion performing a new and unfamiliar dance. Even the stars would refuse their ancient precision. Constellations such as Orion or the Big Dipper might appear subtly shifted, not because the stars themselves move, but because the road light uses to reach your eyes has changed. This bending of light is what allows us to see eclipses perfectly aligned, gravitational lensing revealing galaxies that lie hidden behind others. Distant light curves around massive objects, teaching us the shape of space. With weaker gravity, that shape softens and the universe appears out of focus. Astronomers would detect the change first. Their instruments track the exact arrival of photons from distant stars and pulsars. Any alteration in gravitational strength reveals itself through timing, through tiny deviations in positions that have been stable for decades or centuries. They would notice the stars drifting, not because the stars are moving, but because Earth's gravity is no longer guiding light as it once did. Navigation systems, especially those used by spacecraft and satellites, rely on this consistency. A weakened gravitational lens would introduce errors in measurements that once felt absolute. Even GPS on Earth could become confused as signals from orbit bend differently across the changing atmosphere. On the ground, the human eye would slowly adjust to new rules of perspective. Objects in the distance might seem slightly misplaced, their light arriving along altered pathways. Mountains could look oddly softened, as though leaning under the gentle influence of a new and imprecise horizon. Mirages, those illusions created by heat and light bending through air, would become easier to form and stranger to understand. Light would take longer, more meandering routes to reach your vision, altering what appears real. Even reflections in water would warp in unexpected ways. Ripples on a lake might distort sunsets into shapes that feel like paintings, reimagined by unfamiliar laws. Consider starlight that leaves a distant sun and travels across the galaxy for thousands of years to reach Earth. It has trusted gravity to guide its path faithfully. If that trust weakens, light may arrive from a direction that no longer matches its origin. The universe would feel slightly tilted, as if our cosmic map were drawn on soft parchment beginning to curl at the edges. Solar halos, rainbows, and atmospheric optics would become more dramatic. Colors could linger in the sky long after the sun has dipped below the horizon, light taking slower curves through a softer gravitational well. Astronomers measuring gravitational lensing from massive clusters of galaxies would record diminished arcs, less stretched images of the universe behind them. The cosmos would seem flatter, its deepest structures less pronounced, and that flattening has consequences for our ability to observe the origins of everything. Without gravity's strong influence on light, black holes lose part of their mystery. Their event horizons, once perfect traps for light, become less absolute as the very membrane of their influence weakens in turn. Even the simple experience of watching a sunset would change emotionally. Right now, the sun dips below the horizon and light bends over the curve of Earth, giving us the last soft glow long after the disk has disappeared. That lingering moment of color depends on gravity's ability to guide light around the planet. If gravity weakens, sunset would become abrupt, the colors would fade sooner, night would arrive with less negotiation, the world would feel more divided between light and dark, less gentle in its transitions. Communication networks would confront a new challenge. Every signal, whether radio or satellite or laser, travels along light's pathways. A shift in how those paths bend changes how information arrives. Timing becomes less precise. Signals arrive late or early by fractions of a second that accumulate over time. Our trust in clocks and satellites, in synchronized systems, would have to be rewritten. For centuries, sailors used the stars to cross oceans. Pilots navigated the night sky by the moon and constellations. Even today, astronomy remains the backbone of timekeeping and positioning. Take away gravitational certainty and the celestial compass begins to mislead. We would learn to adapt, but the adjustment would feel like stepping into a world where the rules are being redrafted quietly. And yet, this is still a gentle change compared to what comes next. Light is not the only thing that travels through space-time. Mass does too. Planets and stars follow gravity's instructions. If those instructions fade, their motion loses discipline. Galaxies themselves might loosen their spirals, stars drifting farther from their home arms. What begins as a subtle shift in the way dawn light curves ends as a fundamental challenge to the structure of the universe. Everything we see depends on where light has been. Everything light has been depends on how gravity shapes its road. So if that shaping continues to change, the story of the cosmos becomes harder to read. As we follow this quiet unraveling, one more question arrives. What holds the future together when the forces that shaped the past grow uncertain? Now we drift into the next chapter, where the greatest structures of existence begin to slip apart. Part 14. A universe that forgets its structure. Stars form by collapsing under gravity's embrace. Galaxies hold their spirals because gravity keeps them wound tight. If the rules changed, even faintly, the cosmos would loosen into drifting fragments, a quiet unraveling across billions of years. Everything we see in the night sky exists because gravity once held a gathering. It draws scattered clouds of gas together, compressing them into the blazing hearts of stars. It sweeps those stars into spiraling disks, binding them into galaxies that swirl across cosmic time as if choreographed by a steady and eternal rhythm. But gravity is not eternal. It is only as strong as the laws that allow it. If those laws shifted, even by the slightest fraction, that rhythm would change. The universe is a balance between expansion and attraction. Space-time stretches outward, carrying galaxies away from one another, while gravity tries to pull them together. Today, that balance is already delicate. We see distant galaxies receding, their motion a reminder that space itself continues to grow. If gravity weakens further, the expansion wins. Galaxies like our own Milky Way might begin to soften in shape. The elegant arms that wind outward from the center would loosen, their stars drifting farther apart as the gravitational thread holding them tight thins quietly. Star clusters would widen. Binary stars, two suns locked in mutual orbit, might drift just enough to lose each other after millions of years of companionship. The night sky from any planet would feel less dense, fewer stars painting the horizon, the darkness between them growing deeper. New stars would be harder to form. The gas clouds that collapse into brilliant newborn suns would struggle to gather. Without enough gravitational pressure, they might simply linger as vast, cold nebulae that never ignite. This means the universe would slowly switch off its lights. For now, star birth continues in stellar nurseries scattered throughout the galaxies. But if gravity cannot gather the necessary ingredients tightly enough, the cosmos enters a long night where new stars become rare and old stars fade one by one. Even the stars that do exist would behave differently. Gravity compresses their cores, fueling the nuclear fires within. With weaker gravity, a star's internal pressure shifts. The balance between fusion pushing outward and gravity pulling inward tilts into unfamiliar patterns. Some stars might swell larger than expected, cooling into faint red giants sooner than they should. Others might burn fuel wastefully, their lifespan shortened as their cores lose structure. The predictable life cycle of stars from birth to supernova would become less certain. Black holes, the densest objects in the universe, depend entirely on gravity's power to trap even light. If gravity weakens, their horizons could shrink. Some black holes might evaporate over cosmic ages through processes already known to physics, but accelerated now by the failing ability of gravity to keep them intact. Dark matter, a mysterious substance that holds galaxies together, would also feel the change. Though invisible, it exerts gravitational pull that shapes cosmic structure. With gravity weakened, its influence diminishes. The scaffolding upon which galaxies rest begins to falter. Cosmic filaments, the vast bridges of matter that stretch between galaxy clusters, would thin and contract. The universe's great web would lose its tension, leaving islands of stars adrift in wider seas of emptiness. The accelerated expansion driven by dark energy would no longer face a strong opposing force. Space would spread faster, more recklessly. Galaxies that today still share distant relationships would drift beyond sight as their light can no longer reach us. Future astronomers, if any remain, might look at their sky and see only a sparse scattering where once there were endless galaxies. The universe would appear smaller, not because it is shrinking, but because its contents have slipped into distances that light cannot overcome. It becomes a lonelier cosmos. Planets, too, depend on gravity to remain whole. Weaker gravity means they could swell slightly, their crusts less tightly held to their molten cores. Volcanoes and mountains would change behavior over unimaginable timescales. Moons orbiting distant worlds could wander outward, mirroring what would happen to our own moon. Planetary systems once bound by clear dynamics would grow unstable. The story of orbits would turn from poetry into uncertainty. And yet, this unraveling would be gentle, spread across billions of years. There would be no sudden catastrophe, no rapid collapse or explosion. Instead, the universe simply relaxes, structures loosen, patterns fade. It is not destruction, but forgetting. Gravity is memory. It remembers every star and planet, every cluster, and galaxy, keeping them gathered in the shapes they have always been. If that memory weakens, the cosmos becomes forgetful. Galaxies forget their spirals, stars forget their companions, the universe forgets its clusters. Ultimately, this cosmic forgetfulness leads toward what some physicists call the heat death of the universe, a slowly cooling expanse where energy spreads too thin to create structure or change. No stars, no light, only drifting particles in endless night. That is the far future. A time so distant that human imagination strains to reach it. But the seeds of that fate are planted the moment gravity changes. And yet, as we contemplate this vast unraveling, one more reflection rises quietly. If the universe forgets the structures that shaped its past, what then becomes of the most intimate structures closest to us? Gravity does not only hold galaxies together, it holds each of us to the ground. It gives form to our experience as much as it does the cosmos. So the final question lingers. What happens when the very laws that built the universe begin to drift away from the world we once knew? Now, we move into the last chapter, where the future of everything rests in the quiet tension between collapse and escape. Part 15. The laws we take for granted. At the heart of physics lies one truth: the universe remains consistent. But if gravity altered, even for a breath, every law built upon it, motion, time, stability, would rewrite itself in silence. Every second of your life is supported by rules so dependable you do not need to notice them. Objects fall. Days follow nights. Time flows smoothly forward. The ground stays secure beneath your feet. These are assumptions older than memory. But all of these ideas rest on a foundation we rarely consider. Gravity is not only a force pulling down, it is a framework that tells the universe how to behave. Change that framework, and the familiar becomes unfamiliar without a sound. Take motion, one of the simplest principles we know. Newton taught us that objects remain still or move straight unless pushed or pulled. Here on Earth, gravity is always that pull, always adjusting motion toward the ground. It defines balance, determines inertia, and decides how objects collide. Without gravity's steady guidance, a gentle shove could send something drifting sideways far longer than expected. Momentum would no longer fade into friction and weight. Playgrounds, highways, and daily gestures would lose their predictability. Even the rhythm of a pendulum that once kept perfect time would lose its beat. Clocks designed around gravity's swing would run fast or slow or not at all. Time itself depends on gravity. Einstein showed us that clocks tick differently depending on how strong gravity's pull is at their location. Disrupt that pull, and time slips out of synchronization. Seconds stretch or compress without announcement. In a world where gravity changes, two identical clocks on opposite ends of a room might disagree about what moment they are living in. Tiny fractures like these grow wider the more the laws drift. Consider energy. The way it moves, transfers, converts into heat or motion requires gravity to shape the environment. Thermal convection, weather, the cycling of air and water all depend on warm things rising, cool things falling. Take that away, and the engines of Earth slow to new patterns that no scientist has mapped. Electricity and magnetism are deeply intertwined with motion. Change the motion of particles by altering gravity's influence, and even sparks may behave like strangers to their own nature. Foundational rules do not break loudly, they soften one assumption at a time. Take stability. Structures stand because they are anchored to a ground that pushes back with the force of gravity. We build vertically with confidence that down remains down. If that certainty fades, architecture must learn new languages of support. Buildings might bow outward, roads warp into unfamiliar curves. Bridges require constant correction just to remain level. Even safety changes. Seatbelts, helmets, guardrails, parachutes all exist because gravity promises a fast fall. If falling slows or becomes unpredictable, danger transforms too. It becomes slower, stranger, harder to foresee. On the cosmic scale, orbits collapse or drift. Planets slip from paths that once guaranteed stable seasons and climates. Galaxies spread apart under the increasing influence of expansion. Physics is not a set of separate rules, it is a tapestry. Pull a single thread and the pattern shifts everywhere. Gravity's subtle power is the anchor for everything else. Even chemistry is shaped by it. Atoms collide and bond based on temperatures and pressures that gravity enforces. Without the weight of atmosphere pressing downward, fire burns differently. Evaporation changes pace, and reactions proceed in slow and hesitant dances. Biology follows chemistry. Life adapts to forces that stay constant for millions of years. Bones grow heavy only if weight demands it. Cells transport nutrients only if fluids flow in a world with a clear direction of down. Evolution itself is tuned to gravity. If that tuning breaks, life must change or fade. And yet, if gravity weakened only slightly and only briefly, most people would not notice a universe rewriting itself in the margins. A ball thrown might drift just a little too far. A clock might tick just a bit strangely. Stars might twinkle in odd new positions, subtle hints that the foundation has begun to tilt. Physics does not scream when its laws change, it whispers. A scientist studying electrons might notice a number that should be constant quietly shift. An engineer designing a bridge might find equations no longer match reality. A pilot might observe that a flight path curves a little wrong. Hints, warnings, a gentle tremor beneath the familiar. And humans, as we always do, would question ourselves first, not the universe. But in time, patterns would escalate. Systems depending on accuracy, time, navigation, communication would fall out of sync. Currencies could crash not by economics, but by physics. Satellites could stray, missiles could misfire, all because gravity no longer tells the same story. We cling to the belief that physical laws are eternal. The speed of light, the charge of the electron, the strength of gravity. These are the pillars of understanding. If one shifts, even slightly, the structure built upon it must adjust everywhere. It would begin as confusion, then uncertainty, then adaptation. We would build new instruments, new methods, new mathematics to reinterpret the changing world. Eventually, a generation would grow up knowing no alternative. For them, the drifting apple, the slow descent, the softly bending light would feel normal. The universe would not be broken, it would simply be different. But deep in the fabric of existence, a question would remain. Why did gravity change? If the EBAS laws can shift once, they can shift again. The comfort we take in the sky's predictability, in the ground's solidity, in time's forward motion comes from a trust that physics is unchanging. To lose that trust is to lose the assurance that tomorrow will resemble today. In the end, the quiet power of gravity reminds us that the universe is held together not by certainty, but by balance. A balance that could slip with nothing more than a silent adjustment in the rules we take for granted. And so we arrive at the final edge of wonder. Our world, our bodies, our cosmos all depend on a force that has no voice but shapes every moment. If it keeps weakening, there comes a moment when structure lets go, motion changes meaning, and existence itself becomes unfamiliar. But if it remains even just as it is now, we can continue to live and wonder under a universe held together by invisible care. Now we drift forward into the closing thoughts, where calm perspective and quiet reflection help us return to the comfort of the world as it still is tonight. Even as you rest here now, gravity holds you close. It guides your heartbeat, keeps the air thick enough to breathe, and steadies the ground beneath your quiet stillness. All of the wonder we explored tonight begins with that simple truth. We imagined a universe where that quiet force changes, where oceans wander, stars drift, and the moon slowly releases its embrace. A future where the familiar rules soften into new forms and the cosmos rewrites itself in silence. But for now, gravity remains strong. The sky stays stitched to the earth, water holds its place, and each sunrise returns right where it was supposed to be. Tonight, you can feel grounded in the comfort of what is real. The laws of nature still stand firm, patient, and ancient, gently shaping the world as we fall asleep beneath them. Thank you for exploring this quiet journey with me. If this calm story brought you even a moment of peace, I am grateful you are here. A gentle like or a soft tap on subscribe would mean more than you know. For now, close your eyes. Let stillness gather around you like the embrace of the earth itself. Let your breath slow, your thoughts drift, your body sink into the gentle pull of a universe that cares enough to keep you close. Rest well, and may the quiet certainty of gravity carry you softly into sleep.